All right, ready to dive deep. Today, it's all about carbonaceous aerosols. These tiny particles are everywhere, and they have a huge impact.
They really do. They're a key piece of the puzzle when we're talking about climate change and air pollution.
Absolutely. And we're going to unlock their secrets with this amazing tool called the CASS, the Carbonaceous Aerosol Speciation System. By the end of this, you'll be an air quality expert.
It's pretty fascinating stuff. The CS has really changed how we understand what's in the air we breathe.
For this deep dive, we've got a ton of information from the company that makes CASS Aerosol Magee scientific. And these folks are seriously passionate about this technology.
It seems like they really believe in the power of this system.
They do. What's really cool is this system can tell us about all the different types of carbon in the air. And not all carbon is created equal. Some of it's pretty nasty stuff, impacting everything from the planet's temperature to our health.
You've got it. If you want to understand the big challenges facing us, climate change,
Yeah.
air pollution, you got to understand these particles. They're tiny, but they pack a punch.
So let's break it down. What exactly are carbonaceous aerosols, and why should we care so much about them?
Well, think of them as tiny bits of carbon floating in the air. They're a major part of what we call PM2.5, that fine particulate matter you hear about in air quality reports.
Okay, that makes sense. But carbon is everywhere, right? What makes the carbon in these aerosols so special?
It all comes down to the type of carbon. These aerosols are incredibly diverse. We've got organic carbon, or OC, and elemental carbon, or EC.
Ooh, I love a good acronym. Tell me more about this OC and EC duo.
Think about all the stuff that comes out of cars and trucks, exhaust fumes, tire particles, all that. That's a major contributor to OC.
Ah, so traffic is a big source of organic carbon.
It is, and it's not just cars, industrial emissions, and even wildfires pump out a lot of OC. It's a complex mix of chemical compounds, and some of them can be harmful to our health.
So the organic carbon is kind of a mixed bag, coming from both natural and human-made sources.
Exactly, and it's that complex chemical makeup that makes it potentially risky for our health.
And what about EC, the elemental carbon? Where does that come from?
Elemental carbon is all about incomplete combustion. Think about those billowing smokestacks you see in industrial areas, or the black smoke coming out of diesel trucks. That's EC.
Ah, so EC is the sooty stuff from burning things.
Right. It comes from burning fossil fuels like coal and oil, or even from wood burning.
And I'm guessing it's not doing our lungs any favors.
You guessed right. Inhaling those particles can cause all sorts of respiratory problems. Plus, EC absorbs sunlight, which contributes to global warming.
So we've got these two main types of carbonaceous aerosols, OC and EC, each with its own set of sources and impacts. And that's where this CASS system comes in, right?
Precisely. The CASS was designed to measure all those different types of carbon floating around in the air.
Okay, so it can tell us how much of each type of carbon is present.
Yes, we're talking total carbon, elemental carbon, organic carbon, and black carbon.
Wait, black carbon. Isn't that the same as elemental carbon?
It's a bit nuanced. Black carbon is a specific type of elemental carbon that's really good at absorbing light. Think of it as the heart of soot, the stuff that makes it dark.
So it's like a subset of elemental carbon, the super absorbing kind. Okay, I'm starting to get the picture. Now tell me more about how this CRAS actually works. It sounds pretty high-tech.
It is. The CASS has two main parts that work together. The first is called the aethalometer.
Aethalometer. That sounds like something straight out of a sci-fi movie. What does it do?
Well, it measures black carbon in real time. It collects those aerosol particles on a filter tape and then shines light through it. The more soot on the filter, the less light gets through.
So it's measuring how much light the soot is blocking. Clever.
Exactly.
Yeah.
And here's the really cool part. The aethalometer can actually tell the difference between black carbon from different types of sources.
Hold on, so it can actually tell if that black carbon is from cars or a fireplace. That's amazing. It's like having a detective tool for air pollution.
It really is. It can distinguish between the black carbon coming from diesel engines versus the black carbon from wood smoke, for example. And get this, it doesn't even need to be calibrated.
No calibration needed. That's impressive. Why is that?
It works with ratios. Even if the light source changes, the measurements stay accurate.
That's really clever. So the aethalometer is the black carbon expert. What about the second part of the CSS system?
That would be the total carbon analyzer, or TCA-08. It measures, well, the total amount of carbon in the sample.
Okay, so it's not picky. It just measures all the carbon it can find. How does it do that?
It collects those aerosols on a quartz filter and then heats them up to a blazing 900 degrees Celsius.
Whoa. 900 degrees, that's getting things really hot.
It is. That intense heat turns all the carbon in the sample into carbon dioxide, which the analyzer then measures. Simple, but effective.
So it burns everything up and measures the CO2. That's a neat trick. Does the filter survive?
Oh, absolutely. The quartz filter can handle those extreme temperatures. It's designed to withstand the heat without being damaged.
That makes sense. So the aethalometer gives us black carbon, and the total carbon analyzer gives us the total carbon. What's fascinating here is how those two measurements work together to give us the full picture of those carbonaceous aerosols.
Exactly. That's where the magic of what's called the TCBC method comes in.
TCBC. Tell me more about that.
You see, the CLSS takes those two measurements, the black carbon from the aethalometer and the total carbon from the total carbon analyzer, and then it does some simple subtraction. Total carbon minus black carbon equals organic carbon.
Ah, I see. It's a bit like solving a puzzle. You're not directly measuring organic carbon, but you're figuring it out based on the other two pieces of information.
You got it. And this method is actually more reliable than some older methods for separating organic and elemental carbon.
How so?
While the older methods could be affected by the type of analysis used, this one is much more consistent. Plus, it does all of this in near real time, which is pretty remarkable.
Real-time measurement. That means we can get information about these particles as they're happening, not just afterward. That's a big deal, right?
Absolutely. And that real-time aspect is especially important for the aethalometer, which can give us measurements every second. Think about the level of detail that provides.
Every second. Wait, that's mind-blowing. It's like watching a pollution movie in high speed. What's the benefit of having so much detail?
It lets us see very specific pollution patterns. We can see how they relate to the weather and even pinpoint individual sources of pollution.
Wow, so you could actually see how pollution levels spike when a specific factory starts operating or when traffic gets heavy during rush hour. That's incredible.
Precisely. This level of detail is incredibly valuable for air quality management.
Okay, I'm really starting to see how powerful this CASS system is. It's not just about measuring carbon, it's about understanding where it's coming from, how it changes over time, and what all of that means for us and the environment.
Exactly. And to top it off, the CASS has been tested and validated by leading research institutions all over the world. It's not just a fancy gadget. It's a tool that's been proven to be accurate and reliable.
So it's the real deal, backed by science. That's reassuring. Now, I'm curious to hear more about the real-world applications of this technology. How is all this data actually being used?
Well, for starters, it's helping researchers understand the sources and impacts of these carbonaceous aerosols. This data can be used to track pollution trends, see if those emission control strategies are working, and even develop early warning systems for pollution events.
So it's not just about collecting data for the sake of it. It's about using that data to make informed decisions and potentially clean up our air.
Precisely. And it's not just about research either. Air quality agencies are using this data to monitor pollution levels and make recommendations to protect public health.
So they're using it to make real-time decisions that could protect people's health.
Yes. For example, if black carbon levels are particularly high in a certain area, they might issue a health advisory recommending that people limit their time outdoors.
So it can actually help protect people's health in real time. That's amazing.
Absolutely. And that's just one example. The potential applications of this technology are vast. We're just scratching the surface of what we can do with this kind of information.
It's incredible to think that something as tiny as a carbonaceous aerosol can have such a big impact, and how this CASS system is helping us understand and manage that impact.
It truly is a remarkable tool, and we're only just beginning to tap into its full potential.
This has been an incredibly insightful conversation so far. We've learned about the different types of carbonaceous aerosols, where they come from, their impact, and how this amazing CASS system is helping us understand these tiny but mighty particles. Stay tuned for the next part of our deep dive, where we'll dig even deeper into the specifics of the CASS and see some real-world examples of how it's being used.
You know, going through all this material on the CARES, it's amazing to think about all the things it can do. Like, the level of detail is incredible.
It really is. We were just talking about how the aethalometer can measure black carbon every single second. That's mind-boggling.
Yeah, it's like having this high-speed camera for pollution.
Exactly. And that kind of granularity, that detail, it really opens up a whole world of possibilities. For instance, the source material mentions a study about the campfire, one of the deadliest wildfires in California's history.
Oh, right. The campfire. That was absolutely devastating.
It was. I remember seeing the images of the destruction. Horrible.
Yeah.
How did the CASS help researchers understand the impact of the fire?
Well, they use the CASS to track how the levels of carbonaceous aerosols changed, before, during, and after the fire. And the data showed this huge spike in black carbon and organic carbon levels as the smoke from the fire spread.
That makes sense. You'd expect a lot more of those particles in the air with a fire that massive.
Exactly. But here's where the high time resolution of the CS really shines. Researchers were able to see a distinct difference between the initial phase of the fire, where, primary organic aerosols from the burning wood were dominant, and then a later phase where secondary organic aerosols formed.
Secondary organic aerosols.
Right. These are ones that are formed through atmospheric reactions. They became more significant later in the fire.
So they could actually watch how the makeup of the smoke plume changed over time.
Yes. And that's crucial for understanding those long-term health and environmental impacts of wildfires.
Hmm.
It's not just about, the immediate smoke exposure. It's about how those particles change and interact with the atmosphere over time.
Right. It's a stark reminder that these air quality issues are far more complex than we might realize at first. It's not just about measuring pollution. It's about understanding the chemistry, the sources, the long-term effects.
You're absolutely right. And that's precisely why tools like the TAS are so valuable. They give us the data we need to untangle all those complexities and find solutions.
The material also mentioned that the CASS can distinguish between black carbon from different sources. Like, it can tell if it's from fossil fuels versus biomass burning. How does it do that?
That's all thanks to the aethalometer's multi-wavelength analysis capabilities. Different types of black carbon, they absorb light in unique ways, you see. And it all depends on their origin. For example, black carbon from a diesel engine, it absorbs light differently than black carbon from a wood fire.
So it's like a fingerprint for black carbon.
That's a perfect analogy. By analyzing how the light is absorbed at multiple wavelengths, the aethalometer can actually identify the relative contributions of different sources to the overall black carbon levels.
Wow, that's incredible. It's like having a detective tool for air pollution. You can track down the culprits.
It really is. And this kind of source apportionment is crucial for developing, those targeted strategies to reduce black carbon emissions. If you know where the pollution is coming from, you can focus your efforts on tackling the biggest offenders.
So if you see that a certain area has high levels of black carbon from traffic, for example, you could focus on implementing policies to reduce vehicle emissions in that area.
Exactly. And that's just one example. The possibilities are kind of endless when you have this kind of detailed information about pollution sources.
All this talk about black carbon takes me back to our discussion about the TCBC method. The documents really emphasized that it's important to be clear about the relationship between black carbon, which the aethalometer measures, and elemental carbon, which is often determined through thermal analysis.
Yeah, that's a really important distinction. While they are closely related, they aren't exactly the same thing. Black carbon is a specific type of elemental carbon that strongly absorbs light, and that's what the aethalometer directly measures.
Right, but the traditional methods for measuring elemental carbon involve heating the sample and analyzing the carbon that's released, right?
That's right. And there are all these different ways to do that, each with, its own assumptions and potential biases. And as we saw in the source material, the results for elemental carbon can vary significantly depending on the method used.
Yeah, it seems like that would make it really hard to compare data from different studies or monitoring networks if they're using different methods. It's like trying to compare apples and oranges.
Exactly. And that's why it's so important to be transparent about the methods used and to understand the potential limitations of each approach.
And the TCBC method, by using the aethalometer's direct measurement of black carbon, kind of bypasses some of that ambiguity, right?
Precisely. And by combining it with that total carbon measurement from the total carbon analyzer, it provides a more robust and reliable estimate of organic carbon as well.
And all of this happens in real time, without needing any special gases or fragile glassware.
Yeah.
It just sounds incredibly practical.
You got it. The material repeatedly emphasizes the Sega system's ruggedness and its suitability for use in the field, as well as in the lab. It's built to withstand the elements.
It sounds like that ease of use and reliability are key factors in the CASS's popularity among researchers and air quality agencies around the world. It's a tool you can trust to perform consistently, no matter where you take it.
Absolutely. Its ability to provide a complete characterization of carbonaceous aerosols in a user-friendly package has made it the go-to tool for a wide range of applications. It's a real workhorse.
This deep dive is really highlighting the versatility of this system. It's being used for everything from monitoring air quality in bustling cities to studying the impacts of wildfires in remote locations.
Oh, it's used for even more than that. The material mentions its use in studying climate change, assessing the effects of air pollution on public health, and even understanding how those secondary organic aerosols are formed.
It's amazing to think about how this one instrument is contributing to so many different areas of research and decision making.
It really is.
It's a real game changer.
It speaks to how fundamentally important it is to understand carbonaceous aerosols. These tiny particles, they play such a significant role in our climate system, air quality, and health. They're everywhere, and we need to understand them.
One thing that stood out to me as we go through all this material is the sheer volume of research that Aerosol Magee Scientific has produced on this topic. They clearly see this CASS as a transformative technology, not just for their company, but for the entire field of air quality science.
I agree. They haven't just developed this technology, they've really invested in demonstrating its capabilities and promoting its use across all sorts of applications. It seems like they're really passionate about making a difference.
It's like they're on a mission to raise awareness about how important it is to measure and understand carbonaceous aerosols. They want everyone to know about these particles and, the impact they have on our world.
It's a mission worth supporting. The more we know about these particles, the better prepared we'll be to address the challenges they pose to our health and the environment.
Well said. And speaking of supporting this mission, the source material also provides this list of institutions around the world that are using the CASS for their research and monitoring efforts. It's quite a list, spanning various countries and continents. It really shows the global reach of this technology.
Yeah. It's a testament to the TRS's versatility and its ability to generate valuable data in all these different settings and situations. It's truly a global tool.
We've got places ranging from, the bustling megacities of China to the heart of the Amazon rainforest in Brazil, all using this technology to delve deeper into the world of carbonaceous aerosols.
That global perspective is so crucial. Air pollution is a global problem. It transcends borders. It's a shared challenge that requires international collaboration and data sharing.
It's like a global network of scientists and air quality experts, all connected by this powerful tool. And they're working together to unravel the mysteries of these tiny particles and find solutions to the problems they present.
Exactly. And it's a reminder that even though these particles are invisible to us, they have such a profound impact on our planet and on our lives.
Speaking of impact, the material also goes into the health implications of these carbonaceous aerosols. What are some of the key concerns there?
Well, as we touched upon earlier, these particles are small enough to get deep into our lungs and even enter our bloodstream.
Yeah, and that's not good news. What happens when those particles get inside our bodies?
Well, they can trigger a whole cascade of health problems, unfortunately. We're talking respiratory issues, cardiovascular disease, and even an increased risk of cancer.
So these tiny particles can have serious consequences for our health. That's a sobering thought.
It is, and it really underscores the importance of monitoring these particles, understanding their sources, and taking steps to reduce our exposure to them.
And that's where tools like the CASS come into play once again, right?
Precisely. By providing that real-time data on the levels and types of carbonaceous aerosols in the air, the CSS can really inform those public health measures and guide policies aimed at improving air quality. It's a tool for protecting public health.
It's not just a scientific instrument. It's a tool for creating a healthier world. That's
Yeah.
a powerful idea.
Absolutely. And as we gather more data and really refine our understanding of the health effects of these particles, we can develop even more effective strategies for mitigating the risks.
I'm seeing a recurring theme here. Knowledge is power. The more we understand about these particles, the better equipped we are to protect ourselves and our environment.
I couldn't agree more. Understanding is the first step towards finding solutions.
This deep dive is truly eye-opening. It's amazing how much we've learned about the complexities of air quality and the crucial role that technology like the TS plays in helping us unravel those complexities.
It's a fascinating field, and it's constantly evolving as we learn more about those intricacies of the atmosphere and the impacts of, well, our actions.
And on that note, I think we're ready for the final part of our deep dive. We'll wrap up our discussion about the TS and explore some of the broader implications of this technology and what it means for our future.
I'm looking forward to it.
It's really amazing how much we've learned about these tiny particles just from all this material in the CS. I mean, they're floating all around us.
I know, right? Makes you think about like the air we breathe differently. Like we take it for granted, but there's this whole hidden world in every breath we take, all these particles, all these processes happening.
And the CASS is giving us this front row seat to that world, and not just seeing it, but understanding it, understanding how it impacts us, how it impacts the planet.
Yeah, yeah. That understanding is so important for everything, really. If we're talking about supporting policies to reduce emissions, or even just thinking about like our own exposure, just being aware of the air we breathe. Knowledge is power, right?
Absolutely. The company calls the CASS a game changer for understanding carbon in the atmosphere, that is.
Yeah.
Based on everything we've learned, do you think that's accurate?
Oh, absolutely. The case can measure all these different types of carbonaceous aerosols and in real time with incredible accuracy. I mean, that's revolutionary. Plus, it's so versatile. You can use it for so many different things in so many different settings. It's truly a transformative tool.
So if that's true, what kind of impact could this have on our everyday lives? What can we learn from the case that we couldn't before?
Well, imagine a world where we have this like real-time data on the sources of carbonaceous aerosols and the levels, in every neighborhood, every city, every region. That's the future the case could help us build.
That would be incredible. We could actually see how pollution levels change during the day. We could see where the pollution hotspots are, and we could actually track the effectiveness of clean air efforts in a much more detailed way.
Exactly. And people could make informed choices about, their own exposure. Like, what if you could check your phone and see a personalized air quality forecast, taking into account where you are, your health, even your plans for the day?
That would be amazing.
Mm-hmm.
Especially for anyone with respiratory problems or, anyone sensitive to air pollution. They could plan their activities around when the air is cleanest.
Right. And it's not just about personal choices. Cities and governments could use this data to create better policies to reduce emissions. Like, imagine using this real-time data to manage traffic, or to change how industries operate, even to, encourage people to use cleaner transportation.
So it's not just about gathering information. It's about actually using that knowledge to create a healthier world, a more sustainable world for everyone. That's inspiring.
It really is. That's what makes the chase so exciting. It can totally change the way we think about the air we breathe and how we interact with it.
I think it's safe to say this deep dive has been a success. We started knowing very little about carbonaceous aerosols, and now we have solid understanding of what they are, why they're important, and how the CASS is helping us understand them.
It's been a fascinating journey for sure. I'm glad we could share it.
It's amazing what we can learn when we take some interesting material and, we bring our curiosity and we just dive in. You never know what you're going to discover. This has been eye-opening for me. Like, the air we breathe is so complex, but now I feel informed, empowered.
Me too, absolutely. And hopefully our listeners feel the same way. It's a reminder that even though these particles are invisible, they have a huge impact on our lives, on the planet. But with tools like the CASS and that commitment to understanding and protecting our air, we can create a better future, a healthier future for everyone.
Well said. Thanks for joining us on this incredible deep dive. We hope it sparked your curiosity, inspired you to learn more about the world around you. Remember, there's always more to discover, and we'll be here to guide you through it. Until next time, stay curious.